So for question 4.4.13, the question states that could it be that smoking actually increases survival rates among women? The accompanying data represent the 20-year survival status and smoking status of 1,282 women who participated in a 20-year cohort study. We're going to complete parts A through E. So this is the table. It says here's the smoking status. You have smoker, non-smoker, and then we have the column which represents dead and alive. So therefore here are our numbers. And so eventually we're going to have to find the totals for these two columns. Okay. Now if you look at the age group, okay, so we have a selection here. It says 18 to 24. This is the age group for that one. 25 to 34, 35 to 44, all the way up to 75 or older. Now the first question is asking us what proportion of the smokers were dead after 20 years. The second question is what proportion of the non-smokers were dead after 20 years. And what does this imply about the health consequences of smoking? So the first thing we want to do is we want to be able to first generate the totals of the column. And so the first column that we're dealing with is smokers. So we want to be able to find the proportion of the smokers who were dead after 20 years. So if we take a look at the row that shows the row where it says dead, then you're going to take the number of 134, and then you're going to divide that by the total of that column, which is 565. So we take 134 and divide that by 565. And that gives us 0.237 for the proportions of the smokers who were dead after 20 years. Now, the next column is non-smokers. And again, we're looking for the row that is dead. And so therefore, the total number for that, for non-smokers, is 227. And then we're going to divide it by the total of that column, which is 717. So therefore, the proportion of the non-smokers who were dead after 20 years is taking the value of 227 and then dividing it by the total of that column, which gives you 0.317. Now what we want to be able to do is we want to be able to compare the proportion of the non-smokers who were dead after 20 years and the proportion of the smokers who were dead after 20 years. So then we would state that the proportion of the smokers who were dead after 20 years is smaller than the proportion of the non-smokers who were dead after 20 years. And what this implies is that it is healthier to smoke. Part B. The data in the first table do not take into account a variable that is strongly related to survival status, age. Now the data shown in the second accompanying table give the survival status of women and their age at the beginning of the study. So for example, 12 women who were 35 to 44 at the beginning of the study were smokers and dead after 20 years. So the question asks, we want to be able to determine the proportion of 18 to 24-year-old smokers who are dead after 20 years. So what I've done is, you can see here that you have this age group. So we're only looking at the 18 to 24. So as you can see here, I've used this age group. And so here we have smokers, non-smokers. We have our numbers, and then we have to find a total. So the total for the smokers for this age group is 55. The total for non-smokers is 62. So the proportion of 18 to 24-year-old smokers who were dead after 20 years is 4 out of 55, which is approximately 0.073. And the proportion of 18 to 24-year-old non-smokers who were dead after 20 years is the value of 2 over the total of 62, which is approximately 0.032. Now for part C, they want us to repeat part B for the remaining age groups to create a conditional distribution of survival status by smoking status for each age group. So if we continue for the remaining age groups, what we needed to do is we have to find the total of each particular column, which is what I did here. So we've already known that the total for the first two columns was 55 and 62. We have to then generate the totals for all of these columns. So therefore 5 plus 1, 19 gives you 124, 7 plus 1, 49 gives you 156, and so on. So there are your totals. And then what we're going to do is then we're going to take, since we're dealing with smokers and then non-smoker, so we're looking at the status by smoking status for each age group. So we take the value of 4 and divide that by 55, which gives you 0.073. And then we take the value of 2 and divide that by 62, which gives you approximately 0.032. Now, because we're only focusing on the row for the survival status, in this case, which is dead, we're not using the numbers for alive. So therefore, we're excluding that row because of the question and what it's asking us. So therefore, for the second 25 through 34, we're going to take 5 and then divide it by the total, which is 124, which gives you 0.040. Likewise, we're going to take the value of 7 and then divide that by 156, which gives you 0.045. So again, what we're doing here is we're looking at these numbers here and then dividing it by the totals for each of the column to get these values. And now once we have these values, then we can then generate a bar graph of the conditional distributions from this part. So if we look at the age group of 18 to 24, which is the first age group, we would have 0.073 and then 0.032. If you'd like to take a look at the age group of 25 to 34, then we have 0.040, 0.045, and as we keep going and going and going, you will see that that matches those numbers from the conditional distribution. Now we want to be able to state the appropriate conclusion. So basically what it's saying here is that in almost all of the age groups, smokers had a higher death rate than non-smokers.